Good morning, guys. So just a quick review before you start any packets today. The percent packet you should really have no problems with because it's just a review of doing your part equals percent times whole or your markup or your tip. So what I'm going to quickly do is I'm going to quickly review proportional, non-proportional relationships so you can do your second packet. So the first type of questions you're going to see are equations that look like this: y equals 3/5 x, or something like y equals 3x plus 2. Now the thing to remember is equations we're always going to look at them in this form: y equals mx plus b, okay? And when I look at them in this form, m is always going to be my slope. It's always going to be how much my equation is changing by, or what the rate of change is. B is always what my starting value is, okay? Now, when something's proportional, remember, to be proportional, it has to go up at a constant rate, so it means it has to have a slope, and it also has to start at the origin, or go through the origin on a graph. So in order to start at the origin with an equation, our starting value would have to be 0. So if I take a look at this first equation, y equals 3/5 x, there's no b value, which means that it's the same thing as having a plus 0. So this guy indeed would be proportional because it starts at 0. Okay? Just make sure that you write proportional and explain why. Where if we take a look at the second equation, it has a plus 2, which means it is non-proportional because it starts at 2 and not 0. Okay? So when we take a look at equations, we're looking for that b value. The next kind of example we can have is graphs. Now, remember, when we're dealing with graphs, it's proportional, so we need to know if it's straight and if it goes through origin. Okay, so take a look at this first graph here. It has to fit both of those qualities. So it does go through the origin down here, but the problem is it's curvy, so this graph would be non-proportional. Okay, the second graph, it is a straight line, but the problem is here it does not go through the origin, so once again this would be non-proportional. Our third one goes through the origin and is a straight line, so this would be an example of proportional. Okay, just make sure you explain again on your homework. Example 3, now we have tables. So tables, what we need to do is we need to figure out if they're going up by the same thing. So we need to check the change in y over change in x for every single one, or the slope. So I can go ahead and do 10 over 1, which equals 10, 20 over 2, which equals 10. I can do 30 over 3, which equals 10, and 40 over 4, which equals 10. So because all of my unit rates right here are the same, that means that this guy is indeed what we call proportional. Okay? My second one, though, let's try it. I have 10 over 2, which equals 10. I have 20 over 3. Now 20 over 3 doesn't divide nicely, so we get something like 9 times 3 is 27, so that's too high. 8 times 3 is 24, so 7 times 3 is 21. 6 times 3 is 18, so we get something like 6 point whatever. So it doesn't even matter what our, let me check here. Yeah, we get 6.6 repeating. So because these two numbers, the first two, aren't even equal, we do not have to keep going because we know this has to be non-proportional. Okay? Hopefully this helps, guys. If you have any questions,